Okay, continuing our review for piecewise functions. Here we are given a graph and we're asked to come up with the actual equation. So it's going to be a series of equations and domain restrictions, okay? So first of all, I can find the domain and range pretty easily. By looking at this graph, I know that the domain is going to start at negative infinity. So the domain is negative infinity. And it looks like I get x values continuously all the way over to 4, okay, and including 4. Now the range, if I look at the range, it looks like I start to get y values at negative 6, and I obtain y values, it looks like all the way up to, I don't get any y values at 2, okay? So negative 6 to 2, and then it looks like I start to get y values again from 2, on the right it looks like 2 to 5, but you know that that function on the left is going to infinity. So it's going to be from here to here and 2 to infinity, okay? So this is one of those, it might be, if you're having trouble with this, we might need to do this on a physical piece of paper so you can see me moving around to see that. But if you look at, remember the domain set of x values start at negative infinity and they go as far as 4. That one was pretty straightforward. Y values, it looks like they start at negative 6 and they go all the way up to 2, but they don't include 2 because I have open circles in both of those functions. So 2 is not a part of the solution. That's why I've got to break up my range and I've got a parentheses. Then the range starts back at 2 and it goes all the way up to this point, which is 6. But this arrow over here, this arrow keeps on going. So really I'm going to get range values all the way to infinity. So 2 to infinity, okay? So that's that part. Let me try to erase all of this because that sort of made a mess right before I'm going to start creating the function values. So it looks like I've got 3 things going on here, maybe a little bit more, but I've got 2 lines and then I've got a dot that I need to figure out. So let's figure out this first function over here. So the first function you see over here, this is going to be on the interval from negative infinity to negative 2. So I need to figure out what is it that goes from negative infinity to negative 2 with the parentheses. That's the first function, okay? So if I look at that, ways I can figure this out, I can figure out the slope of this function. So if I look at it, if I were to go up 1 and over 2, up 1 and over 2, every time I do that, I'm back on the line, okay? So that tells me the slope is, remember how this works, if I go up 1 and then to the left 2, okay, that meant positive 1, negative 2. That slope is negative 1/2, okay? So the slope of that line is negative 1/2, and so up 1 and to the left 2, the same thing will be going down 1 and over 2, okay? So that means I would hit the y-axis at the point 0, 1. So 0, 1 is going to be my y-intercept, okay? So a line with a slope of negative 1/2 and a y-intercept of 0, 1, that equation is negative 1/2 x plus 1, okay? So that is the first equation that I have. Okay, now let's figure out the second equation. So let me erase some of these markings to make it a little bit clearer. So the second equation, let's see if we can figure out the slope. It looks like if I go up 2 and over 1, every time I do that, every time I do that, I end up back on the line. So it looks like the slope is up 1 and over 2. So that slope is 2 over 1. So the change in y is 2 over the change in x. That slope is 2, okay? And if I look at the y-intercept is 0, negative 2. So if I look at my slope-intercept form, this equation is going to be 2x minus 2. And if you look at it, where is that in effect, okay? It looks like that's going to work from negative 2 all the way to positive 2, okay? Because I've got an open circle there. But it looks like I've got the same line going on from 2 to 4. So I can write, I've got 2x minus 2, and that works from 2 to 4 with a bracket, okay? So I've got that same line, I've just got that hole right in the middle of the line, so it tells me that I've broken up the domain into a couple pieces there, okay? And so the only thing left is that dot that is all by itself. So that dot, that's what happens when x equals 2. And so when x equals 2, it looks like my y value is 0, okay? So here is the function. You've got negative 1/2 x plus 1, that's this blue line right here, and that goes from negative infinity all the way to negative 2 with a parentheses. And then you've got 2x minus 2. It had to be broken in two pieces. It goes from negative 2 to 2 and from 2 to 4, okay? So negative 2 to 2 and 2 to 4, because that line does not include the value at x equal 2. What happens at 2 is I get a value of 0 for my y-axis. So that is the piecewise function. All this stuff was pretty straightforward, but a lot of details, again, to remember as you put that together. And I will come back and do this. Let me do this one real quick. So let's do this one real quick and we'll call this video a day. So the domain of this function, those are all of my x values. So 0, 1, 2, 3, negative 1, and 2. 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. So 0, so I'm basically just looking at my first value, 0, 1, 2, 3, negative 1, 2. 0, 1, 2, 3, negative 1, 2. My range, those would be all the seconds. So 1, 0, 0, 1. So that's going to be 1, 0, 0, 1, 0, negative 1. Those are all the different values that I get for the range. Is this a function? Okay, for it not to be a function, I would have to have repeated x values. If I look at my x values, they are all distinct. So yes, this is a function because there are no repeated x values. Okay, we'll pause there and come back for the rest of it in just a moment.